All right. Hello, everyone, and welcome to this talk, which has quite a long title. But as you can see, the focus of this talk is going to be how we can make our .NET applications a bit more intelligent by using AI. I'm going to show you quite a few things, going from simple model integrations all the way up to agents. So that's the goal of the next 60 minutes or so. My name is Gill. I come from Belgium, where I'm the CTO of Exebia. We do all kinds of software development at customers, focusing, of course, also quite a bit on AI. I'm also a Pluralsight author, and I actually have two courses that are quite related to what I'll be showing here today. So if you want to dive deeper, take a look at Pluralsight if you have a subscription, and you can also learn a lot more. I'll be going a lot deeper in these courses on what I'm touching here today. So what are we going to be doing? It's quite a lot. I have included a 5-minute high-level overview of some of the terminology around AI. I suppose everyone knows that. If you know all that, you're free to take out your phone for the first 5 minutes or so, and then we'll dive into the meat of the presentation. I'm going to be showing you quite a bit on how you can actually use all kinds of AI in your .NET applications, and we're going to start with using OpenAI in several ways. We're going to look at Azure AI Services. We're going to look at Semantic Kernel. And although that works with agents, I'm not going to show that here because I'm also going to show you its successor, and that is the agent framework. So all kinds of possible ways to enhance your applications and to enhance the user experience. So as said, without further ado, let us dive in. And I'm going to make sure that everyone is on board. Nowadays, that is probably the case, but let's make sure that I don't lose anyone at this point already. So I think we all know what AI is going to be doing, or is doing. Computers used to be doing the thing that we asked them to do. We typed in an instruction, a computer did that very fast, very clean. And now all of a sudden, computers not only can execute instructions, but they can also start thinking and learning. And that's, of course, a big change for us. And that we can actually use to enhance the experience of our users. Because our users, we all had to type in all the code that we allowed them to execute and allowed them to benefit from. Now we can actually go further and integrate models and enhance the user experience. We'll give our users insights in large sets of data. We'll give them insights that they never had before. But we can also increase the experience of our business users or applications, of the business type of applications that we use. And that's a big difference. And that's something that I often see being missed by developers. We're always on the lookout for the newest thing, but we also need to think about how we can actually use all that AI greatness in our applications. And that's basically what I'm going to be trying to show you here today. Oops, I clicked a bit too fast. So the goal is basically showing you how we can create smarter applications. There's all kinds of possibilities there. I think we all know what AI is, artificial intelligence, basically the ability for a machine to do pretty much what we are capable of, to mimic human intelligence. And Gen AI is pretty much a very small subset in that. There's a lot more to AI than what Gen AI is offering us, although Gen AI is getting all the hype. It's a small piece of the whole big puzzle. And it's all, of course, based on what LLMs can do, large language models, which we're going to be using all the time here in today's presentation. So basically, large language models, the large, of course, points to the fact that they're trained on huge amounts of data, which also gives them insights that our brain is simply not capable of. And that's, of course, a big benefit. Internally, of course, although we say they're intelligent, internally they're not. They work with numbers and they work with relations with these numbers, and that's basically how an LLM works. I will talk about it in just a second a bit more, but that's basically what is happening when an LLM is thinking. It's working with numbers in its internal neural network, and that's pretty much what it does. And you hear all these huge numbers. We have a billion parameter model. We have a trillion parameter model. Those are the numbers that it works with, that it finds relations with, and based on that, it can generate a lot of content for us. So how an LLM works is pretty much a very smart prediction machine, a very smart one. It uses lots of statistics behind the scenes, and based on that, it can actually find you the next word in the most probable case. There's a lot of statistics going on behind the scenes. So when you type in once upon a, probably the next word will be once upon a time, and so on and so forth. That is pretty much what an LLM is good at predicting the next word. And all the text that you get back via ChatGPT or whatever model that you're using is in fact doing this. It's very simplistic, a very simplistic way of representing what a model is doing. We all know ChatGPT. There's of course other models, but they all are using the GPT type of approach here. The GPT stands for Generative Pre-trained Transformer, three very important building blocks of what this is all based on. Generative means it can actually create new content. The answers are not deterministic, meaning that every time you ask it the same question, or that you ask it a question, I will ask it a question, we'll get a different response. It's generative, it is not deterministic. Also has, of course, a big consequence when we create our code. I will show that later on. When we ask it to generate JSON, it has a big influence on what it will be doing. The pre-trained, of course, everyone knows that a model is trained. It takes a lot of money and a lot of time to actually have it go through all that information and make all these connections. It has to be pre-trained. It's not something that is constantly updating. A model is pre-trained, it's fixed. Of course, the creators of models can update them, but models don't change on the fly. And the T in the GPT is the transformer part. That is the type of neural network that actually powers all this. And that was actually the big breakthrough when ChatGPT came about a few years ago. We have all kinds of models, text to text, text to image, model, image to text, and so on and so forth. Sound is, of course, also now included. The latest trend that we've now been seeing for quite some time is multimodal. You can ask ChatGPT or Claude to generate text and an image in one go. The models are not just doing one thing anymore. Models are now multimodal, and we can also use that in our applications. Now, when we talk with the model, when you log on to Claude or ChatGPT or you use Copilot, you're in fact talking with the model, and that's in fact the application, because ChatGPT or Claude, what you use is actually an application. And of course, our applications will do the same in just a minute. We are basically talking with the model. Now, we're not really talking directly with the model. You don't communicate from your application directly with the model. Of course, there's an API behind all this. There's an API layer that sits in between, that both ChatGPT talk with, that Claude talks with, Copilot talks with, and of course our applications will also be capable of talking with. Now, talking about the talking part is of course the prompting. A few years ago, the prompt engineer became the big hype. That was where the money was going to be. I think we all are past that stage now, and we all know how to prompt. But I sometimes still see people struggling with this. The actual quality of the prompt gives you also a good quality in the result. If you give it a bad prompt to a model, if you ask it a bad question, a very unclear, very broad, very undefined question, I mean, then the answer is also going to be, well, not what you want, not what you expect. We'll see examples of how we can actually, in our code, be very specific about the prompt so that we can actually expect what is going to come back. If you ask it to say something about history, well, quite broad. It's not going to be a very good answer. It might actually just say nowadays, sorry, that's too broad, what do you mean? Depends a bit on the model and depends on the day possibly as well. And if you are, the more specific you are, the more specific the answer and the better quality the answer will of course be. Now, we are here to see how we can leverage all that in our .NET applications. So if we use ChatGPT, we talk, like I just said, with an API. Of course, our applications can also talk directly with an API. We could directly integrate with ChatGPT, Claude, with an API access that works. Of course, nowadays, for most of these things, there's already SDKs that have been developed. I will show you quite a few of these because, of course, that's a lot easier to work with when we write our applications. And there's quite a few options. This is, I think, a very incomplete list of options that we have nowadays to integrate models into our applications. OpenAI, the one that put this whole thing into motion, has the .NET, quite a difficult one to pronounce. It's the OpenAI .NET API library. I will say it a couple of times wrong during this presentation, I'm 100% sure. It basically wraps the OpenAI API. That's what it will do. I will show you that in just a second. Actually, a lot of people don't know that this exists, but this is actually a very easy way to integrate OpenAI's capabilities into your applications and use them and expose all this functionality to your applications. Azure OpenAI Service actually already has been superseded nowadays, but it was the ability, or is still, you can still use it, is basically the ability to use an OpenAI model, deploy that yourself in your own Azure environment, and have people integrate with that instead of the public one. gives you an additional layer of security, privacy, of course very important in enterprise environments. So this is what you would typically use. The way that you can actually use it, using the OpenAI API library, is actually the same. So I'll show you that in just a second as well. Like I said, it has been superseded by Azure Foundry. I should now already say Microsoft Foundry. So you can still use it, but this has been superseded. But what it does is pretty much the same. Azure AI Services is a whole set of services that Microsoft has been offering for quite some years. This one has been around for quite some years, although they have improved over time quite a bit. You probably have seen all the demos with this, recognition of photos, language recognition, all of that we have had for quite some time. It's built on pre-trained models as well, so pre-built models for you to just integrate via an SDK. I will show you that as well. I'm not going to focus on that too much because it's definitely not new. Semantic Kernel is been around now for about 2 years, I think. That is really the library that made integration of all these APIs a lot easier in your applications, because it actually is an abstraction on top of everything that we had, because otherwise we had to be very specific with the model. I will show you Semantic Kernel. Although Semantic Kernel is still in support, it is actually going to be again superseded by a new framework. Although Microsoft really said this is the one that we're going forward with, they changed their mind. But still supported and still actively being used. We have quite a few applications that we have built on top of Semantic Kernel. I will show you that as well. What I'm not going to show you is the C# MCP SDK. MCP is the protocol that allows you to integrate with tools. That was, let's say, launched by Anthropic, and we have now a C# SDK for that as well. So this is an SDK that allows you to make MCP calls pretty easily. It enables, what MCP is doing, it basically enables you to have models integrate with tools in a standardized way. That's what MCP will do for you. I'm not going to show you that one, again, because of time constraints. Azure AI Foundry, also not really an SDK. There are SDKs, but Azure AI Foundry is really the backend that Microsoft offers to host models in, to do deployments of models in, as well as also it has a lot of optimizations to run agents. This is really the new way of hosting models in Azure. Lots of capabilities. This is not a Foundry talk. I would go way off track if I go into Foundry. So I'm focusing more on the development side of things. This is more like a deployment side of things. And then finally, the newest hit on the block is Agent Framework. We'll look at that as well. This has now been around, let's say, 3-4 months, I think. Since October, Microsoft launched this, I think, in a preview at this point, so it's not final yet. There's a lot of things that are changing still. It is actually the successor of Semantic Kernel merged with AutoGen. I will come back to that in just a bit at the end of the talk. By the name, you can already guess what this is focusing on. This is really focused on the agentic side of things. Semantic Kernel can also do agents. It's a lot of code to actually get it to work. This is focused on an easier syntax to build agents. All right. With that out of the way, so these are, let's say, the high-level overview of the different options that we have today to do the integration and what I'm going to be focusing on. Now I will dive into each of these silos a bit more in detail. All right. And we'll start with where I also just started with OpenAI in .NET. So we all know OpenAI, the company that, like I said, set this whole thing on fire. They've created quite a few models, ChatGPT being the most commonly used one, their chat model, but DALL-E, image-focused, also been superseded by ChatGPT images, Whisper, they have Codex, they have all kinds of models focused on specific things. The good thing, everything that I'm showing here today, you can use on all the different models as well. 4.0, 5, whatever you want to use, it's always the same. The name of the parameter that you use is just a value that you pass in, a parameter that you pass in. So whatever we do here, you can use on whatever model that you want. They have a very extensive API. In fact, ChatGPT also uses this. So all the things we use, they're also exposing through an API. That is also very well documented. I'll show that in just a second. So you can actually use that API directly in your .NET applications. It's an HTTP, it's a REST API. We can use that directly in our applications. It requires an API key. It's not free to do this in your applications. Important. Meaning that you will have to pay for every request based on the amount of tokens, the number of pieces of text, let's say, that go in and out. that is required that it's paid for. Sometimes it's most of the time cheaper to host your own models rather than use the public ones. It doesn't, even if you have a plus subscription, a paid subscription for ChatGPT, this one is not included. So the API access is a separate payment thing that you have to take into account. So it's an API, so it probably won't be a surprise that you use a bearer token. As that's the API key that you send along with the request that you make to the API, and the request is just some JSON, as you can see here. So you pass in a couple of parameters like the model you want to use. It has defaults for all these things, by the way, as well. You pass in the messages. You can pass a whole set of text messages as the context that it has to work with. You pass in optionally the tokens, the amount of tokens it can maximum use by maximum. That's the number of to limit the length, let's say, of the response that comes back. And a temperature you can also pass in, but it also has defaults, but the temperature is a value between 0 and 2 in the case of ChatGPT. 2 being a very, then it probably will go way more off track. It will start doing more creative responses, let's say. Yeah. Not what you want. Typically, we'll put it around 0.7 to 1. That's typically where you put the value of the temperature. All right. Now, like I said, they have a very good documentation site. It's called the platform site. There you go. No. There you go. So if we go to platform.openai.com, you will see, let me make this a bit bigger. This I forgot to increase, sorry. So they have, if you go, for example, to the text generation part, so you go to platform.openai.com, all the things on the left here are the different parts of the API that they expose. And here you can see, for example, this is already in C#. They have C# documentation now. This is actually, if you want to directly use the HTTP access, you just get the curl request. You see this is using ChatGPT 5 Nano. You have the input, the parameters change sometimes a little bit depending on the model. So the response is the JSON that you send in, and you will get back a response that you then need to parse. Plain HTTP request. I don't think that is what you will use most of the time because there is easier options. You can already see here that they have a C# SDK. Indeed, they do. So that is probably, if you want to directly integrate with their SDK, their models, the way to go forward with. So some time ago, they released the OpenAI.NET API library, an SDK that you just drop in your applications as a NuGet package, nothing more, nothing less. It basically wraps all the HTTP stuff. I think everything that is in the API is wrapped in the latest version, the 2.80, I think it is now. It supports all the models, so DALL-E, Whisper, but also the text models, the code models, all of that is supported. And of course, it also requires an API key. I haven't shown you the API keys. You can, of course, create those via the platform site as well once you pay for it. So you include the API key, and you can directly access that from your code. Very simple API, or I should say SDK. It all starts if you want to do very basic chat completion in your application. You create a chat client, you pass in the name of the model, you pass in your API key, and you have a working chat client. Once you have that, you can ask it to complete the chat. And then you get back a chat response under the form of a chat completion object that you start parsing. The parsing, not always that easy. Sometimes it is a bit deeper in the property tree, but it is actually pretty straightforward to use. This is how you do that in code. I will show it in just a second. By default, a model works, we say asynchronously, but actually synchronous in a way that you send the request and it will wait until it sends back the response until it's ready. The whole response is ready. Typically not what you want, because then you might have to wait for some seconds and your users might need to wait. So you will typically want to have something streaming, which is this code. Streaming can give you like ChatGPT does, the streaming text, the streaming response. You can also pretty simply mimic that in your applications. It's this code which is using the async collection result of streaming chat completion updates. Those updates are the little pieces of text that the model will send, and it's not waiting to send it until the whole response is ready. It's just streaming it into your application. That we can then use in our application to update the user and show that the model is actually doing something. We use an await for each to loop over that, and we show the update, the small streaming updates in the UI. Let me show you that. I have many examples. I won't be able to show them all, because of time constraints. Where is writer? Over here. So this has the NuGet package for the .NET the OpenAI 2.8, so this is the latest one, included, and then we can start using the classes embedded therein. So the chat client I'm creating here, this is pretty much the same code as I showed you in the slide. You pass the model, you pass the API key, and then you do a complete chat. That's pretty much the simplest chatbot that you can build inside of your application. I'm not here to talk about chatbots because I hate them. We're not going to start doing that in our applications. We're going to enhance our applications in just a bit. So if we run this, I think I have this one active. Let me check. Yeah, the simple chat is the one that is active. There we go. So if we run this, so the prompt that I'm passing here is the value that I pass, the parameter I pass to my complete chat, say hello AI world in Swedish, because I did this presentation a couple of weeks ago in Sweden, and then you see it running, and you couldn't see it, but it actually waited until the response was ready. So this is apparently Swedish. So that text is now coming back from the model. Yeah? So we talked with the model in our code. Probably not very mind-blowing. There's another way of doing the chat, in general the integration with the model. So instead of making the chat client yourself, you can use an OpenAI client to which you pass your key, and then you create a chat client passing in the model, and then you use that along the way. This is actually the second one. Second option here is the one that you see people use most of the time. It's a different way of doing the same thing, pretty much. So I'm not going to run it because it will do the same thing. Now what I'm going to show you is actually the one that shows the streaming, because the streaming actually is something we'll want in our applications. So what I'm actually, no, I wanted, sorry, scrolled a bit too far. Like I said, quite a lot of examples, but it's all the same thing, but I actually scrolled past it. I think I wanted this one, sorry. This is the one I wanted to go to. All right. So now you see here that we're using again the chat client, but we now use the async collection of those updates. I'm not going to say the word again. But now I'm asking it to say hello world 20 times in a different language. So that is actually going to stream. It's going to take a bit more. If we wouldn't do it in a streaming way, it would wait and then send the whole thing in one go. Now it's going to stream. We're going to await for each over that, and we're going to update the UI, in this case just the console, all the time. So if I run that, you will see down here that it will start streaming that response after a few seconds. See, there we go. Now it's streaming. Yeah? It randomly will pick 20 languages. It's not always the same. That's, of course, because it's not deterministic. Yeah? What an AI is also not doing is keeping track of what you've already asked it. A model is stateless. Quite normal if you think how many people are basically talking with a model. So a model sends a response and then it says, okay, that's done. I will go and work on the next one. It's not something that keeps state around. Although the ChatGPT or whatever tool that you use give you the impression that it's actually knowing a lot. But that's actually the application that sits in front of the model that passes along the context every time. There is logic behind that to summarize it sometimes, but there's always a history of messages that goes along. So we will actually need to pass, as the developer, the history of messages along with the request to the model. Yeah? That's what I'm doing in this next one here. Let me show you this one. This is an open-ended chat, which actually is going to do a history. So you see here that in this case, I'm now building up a list of chat messages. First, I'm passing in a system chat message, saying to the model, you are this role, this persona. In this case, it's a helpful assistant in I don't know what, in food, I think. Then we have an assistant chat message. That's already the first message that appears in the window, technically, so that's how you can see it. And then I have a simple unending loop, infinite loop, a while true. And what I'm doing here is I'm asking the user, okay, type something, I read that in, and I add that to the list of messages. And instead of now just passing in a single prompt, I pass the whole set of messages to the user, to the model. That's what I'm doing here. Again, in an asynchronous way. If we would run this, well, then we have basically a very simple chat interface with ChatGPT. So it says it can help with food. What is a recipe for a summer pie? There we go. So now it gives me a recipe. If I would now, without history, ask it, what about a wintry one? Right? Then it would not know what I'm talking about. But because I passed it a list of messages, it knows that I'm talking about pies, so it will actually know what to do. Now give me a wintry recipe, I think it's written like this, and it will automatically go and look, see, wintry pie, so it knows because I passed it that list of messages. Cool. So that's how you can pretty easily create a sort of a chat interface in your applications. I'm stopping it here because otherwise it would continue running. Like I said, we can do a lot with this. There's a lot of other options, of course, but we can also use other models. In this case, with the SDK, I use just the chat options, but we can also use it to ask transcriptions of text. We can also ask it to generate images, and that's what I'm doing here. Notice already here, I'm now using the image client, passing in again the model and the OpenAI key, but then I'm creating a prompt here. When you do images, giving a very, very short prompt is probably not going to give you what you want. So this is actually a prompt that I created with ChatGPT to describe an image, to have it create another image. Yeah? So it actually, if you know me, I do all my demos with a pie shop, an imaginary pie shop. So I asked it to do an image of a pie shop. Yeah? That's basically quite a long prompt, as you can see. It goes on and on and on and on and on. This is something that is very specific. A better prompt gives a better result. You can also pass it image generation options, and you can also then ask it to generate the image, which will come back as a set of bytes. Right? I will show it in the next demo because this takes a while to run it. This takes like 30, 40 seconds at least to run it. But so you can see, you can basically do all kinds of content in here. Now, this is cool, but maybe not as cool when you do it just in a console application, because who writes console applications, right? So what I've done is I've created this one, a web shop, actually the backend of a web shop for now. And that web shop is actually going to embed the use of OpenAI directly inside the application. Let me show you that. So what I've just shown you, I've now made practical in the application. So I'm going to log in. So this is the backend, let's say, that we're logging into. There we go. Imagine that you have users, your office users. They need to create new pies in the admin, via the admin pages. So what they'll do is they click here on the Add New Pie. And instead of creating all these descriptions themselves, let me make this a bit bigger so you can see it also in the back. There we go. So I enter here just the name of the pie, right? And now I can ask it to generate a short description, because maybe your office workers aren't very good at that. You saw it filling up, streaming. You can also do a long description. There we go. See, there we go. So this gives a good user experience, and this is really helpful for users, because now they don't have to do that description anymore themselves. Why not also do an image? Let it run for a second, and it will come back with an image that is also already based on a basic prompt that is sitting behind the scenes to set the basics of how the image should look like. Let it run, like I said, it takes a while. What I've done is actually pretty much what I showed you in the console thing. I've actually just brought in a chat client in the PyAd code behind. This is Blazor, so this is a code behind of that Blazor component. I asked it to get that chat client. This is that second option that I showed you. This is using that one. I have a chat client, and when the user clicks on that generate short description, I give it a prompt that says, give me a description. This is for this site, a site that specializes. So I give it a bit of a prompt. Maybe I should do a better prompt, but anyway. And then I use the same code. This is the exact copy of the other one that is then updating, in this case, the UI in Blazor. But I'm again looping through that for each. If we're lucky, we get, yeah, there we go. So now we got the image. The image is actually done in pretty much the same way as I showed you earlier. This is now using the long description, and the one here at the bottom is using the image client with image generation options to generate the pie image. Cool. So this is how you can basically enable all of this in your applications. Now, one thing that I haven't shown you yet is the use of tools. And it's quite important. It's actually very important because a model can't know everything, right? It's good that a model doesn't know everything. Right? Wouldn't be good if a model has access to your contacts, to your sales data, I don't know what. So a model can't know everything. But still, we might want to have our model know about data that only we have internally access to and do something with that. Yeah? For that, we can enable function calling. So function calling is all the stuff around MCP, all the stuff around functions or tools, whatever you call them, it's all pretty much the same thing. It is basically exposing code to the model so that the model can actually ask your application to call that code, execute it, and give it back a second response. So that's the flow that you will actually do. So say that you have sales data, and you have somewhere an API within your organization that you want to expose to the model because you want to ask the model, analyze me my sales data from this year versus last year, for example. Yeah? So what you do is you create a function in your code. That function is then described, and it will go along, the description will go along to the model, saying to the model, this is the prompt, and by the way, I can also help you with this. That's the application that will say, I can help you with this. Yeah? The model then looks at the prompt, and it will see, oh, there's also part of the application that can help me finding the sales data. So it will go back to your application, ask the application to execute that piece of code, a local function, function calling. The model calls into the function, executes that code, goes back with that result with the original prompt to the model. Model knows the data and the original prompt and comes back with a final result. Okay? That is what the function calling is all about. It's an interaction between the model and your application. So this is quite cool and enables a lot of scenarios that aren't possible by default. Right? If I go back to my application, actually I already closed the original one because I'm going to show it here. Let's go back to the console version first. So what is function calling? Like I said, it is basically exposing functions in your application. So this is our code, and our code will say, I have two functions, we call them tools, that we are going to send along to the model. We're not sending the function to the model, we're sending the description to the model. So the functions themselves, the methods I should say in C#, they are down here at the bottom. They are two methods, get the closest Bethany Spy Shop store and get the weather at Bethany Spy Shop store, passing in the location and the degrees unit. Yeah? These are two functions that my application knows about. They could call an API, whatever, right? They can do whatever, they're local functions. But now I'm going to say to my model, hey model, you can actually access those as well. So I'm going to create, again, because of the OpenAI API library, we can actually wrap these functions as tools, as functions that the model can invoke then. We do chat tools. We wrap the functions, you see function name there, and you also have to give them a description. That we now need to send along to the model, optionally with parameters. So as you can see, it's quite a lot of code to do. We'll come back to that. It's now quite a lot of code. But as you can see, we can then create as many functions as you want. Don't go overboard because you will confuse the model. But you can then, when you start talking with your model, now give that list of tools along to your model. That's what I'm doing here. And then, again, a lot of code. I'm not going to take you through all that. But like I said, there is now a back and forth between the model. The model might say, I actually need you to execute this function. So then the model will ask with a finished reason that it needs to do a tool call. You need to then parse which tool the model asks for, execute that, send back a response to the model, and then it will execute, and this while loop will continue running because the tool call can actually be executed multiple times. There's actually a possible back and forth between the model and your own application. So this is what function calling is all about. I use that, for example, in Bethany Spy Shop to actually, let me run it here. Oh, we're still running it. There we go. Let me see where it is. To actually create this sort of sales bot. And again, like I said, I have internal sales data that I'm now exposing. And let me copy this. I ask it to compare the sales of January 2023. Oh, sorry. I need to pass in this. Let me refresh that because it's probably going to stop here. So I'm going to ask it to compare the sales data of last year with this year. more or less. So see, there we go. Now it didn't know about that. That's not public data, but I actually embedded that in my application. So I have in my Bethany Spy Shop application created a function. So it's a sales bot over here. Yeah, there we go. It's the same code as we saw before. And I have included here a function. That's this function. Actually, I should say a tool. And that wraps the function that gives me the number of pies sold in a given month and year. Yeah. So it is up to the model to come back to my application, passing in the number of the month and the year as parameters, because that's what this function requires. So that's also why you have to be very specific with the description of the function, what it can do, function name, function parameters, all of that needs to be described. Yeah. In fact, that's also what MCP is all about. MCP is basically more or less creating a standard around this. All right, so now you see how you can actually do everything that I've already said in your application by just enabling the models and just using the SDK. But we're not done yet, of course not. That's a Blazor application that stopped here. All right, let's go back to the slides for a minute. The other option, the second option that I want to talk to you about is Azure AI Services. Yeah. So Azure AI Services is a set of services, good name for that, where Microsoft has basically wrapped existing models with a very specific functionality and exposes that over SDKs and also over APIs as well. Yeah. So without knowing anything about AI, this is pretty much probably the simplest way to do AI integration in your applications. Yeah. They have SDKs for other languages, so even if you use Python, if you use Java, they have SDKs for that as well that are actually very complete. They can do language stuff, they can do translators, they can do speech, they can do vision, search. Search is actually, so the Azure AI Search is actually also part of this suite of tools, and actually quite a lot of other things as well. So if you, for example, dive into the language part, so the language part can do a lot of stuff, like natural language processing, to analyze text, to understand text, to get the sentiment of text, to get the language, to do translations. All of that it can do with text. So it can do, well, quite a bit. Instead of talking about it too much, let me show you this, because it's actually very simple stuff to get used to. Let's first go to, let me first show it in a console application again, because it's always easier to understand it without the whole thing of the Blazor around it. So let me go to this one here. There we go. Let's use this detect language thing. So again, I've added a NuGet package to this one, and now we are using. Now we again need to use credentials. Depends a bit on the type of service that you use. We are using credentials. Sometimes you also have to give an endpoint URI to which you are going to be talking. That's sometimes required. Now, it actually starts on line 16, the text analytics client, passing in the endpoint and the credentials, and I'm passing in this case a French piece of text. Yeah. And I'm going to ask it to, well, get the language, detect the language. It can't be any simpler than that. So hopefully, if we run this, it will actually detect that this is French. Let's see. So indeed, we gave it that string, and it noticed that the text is in French. Yeah. It can do all kinds of cool things with text, and it can also do it with images, but I don't have the time to show you all that. Say that we, for example, and this is what I'm going to show in the other example as well. Say that we, for example, wanted to get the sentiment of a piece of text. So we then use, again, the text analytics client. And in this case, the text that a user entered as some piece of feedback. Oh, the cheesecake was a huge disappointment, text was grainy, not creamy, and so on and so forth. I just ask it to analyze the sentiment of the whole thing. Yeah? And it will give me back a part positive, a part negative, and a part neutral. And then you can even dive into that and look at per sentence, where is the most negative part located. Yeah? Let's run it, and we'll see, hopefully. This is a huge disappointment, so it's probably going to say that it was actually quite negative. So see, it gave me all that output per, so in general, this is the general part. So 16% is positive, almost all the rest is negative. Yeah? So I thought when I was doing this, I was like, this we can actually use in a sort of a ticketing system. Yeah? Because maybe when we have our app shop, it might be good that we prioritize the things that are negative. Yeah? And so that I actually included in Bethany Spy Shop to prioritize tickets that come in, to summarize them, to maybe also, if they're in a different language, to also translate them, because my support agents only know English. So let's go there and try that out. So this is a different version, but now uses Azure AI. Let's run it first. Log in. There we go. So first I'm going here. I'm going to create a new ticket. Let's say, well, this cheesecake was the most horrible thing I ever ate. There we go. Pretty negative. So this should probably be high in the priority chain, I don't know. Sometimes this goes wrong, apologies, so might have to do it a couple of times. Probably when I do it live. Oh, no, actually wait, the first time. So this is entered by an end user, right? And now you go back to you're the admin, today is the 29th. And so this text is actually built up by Azure AI. It looked at the text, and it actually looked at the sentiment. And it's actually quite negative, right? So it felt that. Yeah? This is a summary that I then created based on the sentiment. And even if we go in, we get some more summary. So we also see a negative smiley. We also detected that it was English. In fact, if I go here and do another one, het was fantastisch. This is Dutch. I speak Dutch. So if I do this, there we go. And I go back to tickets, another ticket was added, and this one is summarized in English because my support agent only knows English. But then I go in here, I see the original one, and it automatically was translated, right? Quite cool, all these things you can do. You can even add, this, it's in the application, I'll show you the code where you can get the code afterwards, but even if you have a whole thread of messages going back and forth, it will summarize that, and that's actually the title that is going to be shown there. Now there's a lot of things actually going on. I say a lot, actually it's pretty simple if you see what you get here. I have that in the ticket data service over here. So when a new ticket, I can't show you all the code of course because of time constraints, but notice when a new ticket, a new message has been added to a ticket, because you can add multiple messages to a single ticket. We use Azure Azure AI to get the sentiment of the message. So we use that text analytics client to analyze the sentiment. I need to determine myself if there is more positive or negative in there, because that's how I will use a yellow, a green, or a red smiley. So this is actually fully done with Azure AI. I also can get a language, the ticket language. Again, I pass in the message, and I use the text, in this case, the text analytics client.detect language. If it's English, we don't do anything. If not, then we actually will also use the translation client, in this case, to translate it to English, so that my support agent actually knows how to do it. Now, the actual summary that you saw is a good example of, actually when I add the whole ticket, is a good example of quite an extensive prompt, let's say. I have this summarized text, a summarized ticket method here, and notice that first I have a list, an array of satisfaction scores, and then I have, if you start reading it, quite a long prompt. Yeah? Because this time, what I actually want to do is I want to ask the model for a couple of things. What is the, I pass it in the list of all messages so that it will give me back three things. A summary, limited to 30 words. That's the one I show in the overview, I think. A short 8-word summary, that's the ticket title, and then one of the messages out of, one of the sentiments out of the satisfaction scores. I do all that, and I ask the model also, please give me this back as a JSON message. Yeah? Don't make this markdown, don't make this HTML. I just said sometimes it goes wrong because sometimes it will still give you a backtick as the first character. Yeah? You can be as explicit as you want, sometimes it still does that. Less and less so, but it still does it every now and then. Yeah? And then I know that I'm getting back from my model, so this is actually, in this case, just OpenAI again. I then actually get back JSON, at least I hope. I can pause that, and this is how you actually see how being more explicit in your prompt will actually merge with code that you need to parse, because we need to parse that JSON because I want to fill in those things in my database. I need a way to actually get that interface right. And that's how I'm very explicit in my prompt to make sure that I get back what I want. All right, I hope that was useful, because now we'll jump to the next one, and that is semantic kernel. Now, the downside of what I showed you earlier, OpenAI's API library, Claude has its, Anthropic has its own SDK. All these models, Gemini, they have all their own SDKs, and it basically means that very early in the cycle, you need to decide which model you're going to use. Maybe today that one is better than that one, so you go for that one, but maybe tomorrow you want to change, so you have to change your entire code base. And in the end, all these models do pretty much the same. They do text, they do images, they do something with transcribing and so on and so forth. And that's basically the idea behind what Semantic Kernel is going to solve. So Semantic Kernel is a library, again open source by Microsoft, that is targeted at is aimed at making all the AI integrations easier. That's what it's aimed at, to abstract the differences away. That's pretty much what it will do. Yeah. So instead of making you dependent on an SDK, you use Semantic Kernel, you use the kernel, which I'll come to in just a second. You give it some services, Gemini, Claude, ChatGPT, OpenAI, and basically then you abstract away the differences. You talk with all these models in pretty much the same way. So you don't make any dependency in your code anymore. They have SDKs for C#, Python. They also have Java, but that's not complete. So Semantic Kernel is really an abstraction layer on top of all of these SDKs. That's pretty much what it is. It's a NuGet package. You still require the API key, and you connect it with a model. Yeah. The whole thing is based around, maybe not surprisingly, the kernel. The kernel is, well, the heart of Semantic Kernel. It's a central component, yeah? And it will take away a lot of the burden. Remember what I showed you, that long piece of code for the tool integration, the function integration. All of that is a lot simpler thanks to Semantic Kernel and the kernel itself. Because to the kernel, you can see the kernel a bit as a DI container. It is in fact a DI container. You can add all kinds of things to it, like logging, but also which AI services you want to use. Oh, I want to use OpenAI, or I want to use Gemini, or I want to use this and that function, right? So that you can all do with Semantic Kernel's kernel. Yeah? So you can actually add all that stuff in the bucket, and then kernel will use it. It's really the link between your code and the model. You start by creating a kernel. So that's what I'm doing here. So you do kernel.create builder, something that probably sounds familiar if you use ASP.NET. And then you use the method or methods of models that you want to use. As AI services, I should actually say. So in this case, I use add OpenAI chat completion, passing in the model, passing in the API keys, and then we have the kernel at the ready. And then we can actually start using it. So then we can, for example, at the most easy, the most simple chat application, say kernel.invoke prompt, and it doesn't matter what is the underlying model. If you flip the model, this code can stay the same. That's the whole idea behind Semantic Kernel. It abstracts us to a layer above all the model dependencies. I'm going to show you in just a second. It also has all the stuff available that all the other SDKs can do. So, for example, the string of messages, or the list of messages for the chat history, well, built in. This knows about that. You have a chat history object or chat history type that you can use to actually integrate with the history. You just add the history's messages to the the messages to the history, and you can just start relying on the underlying history being passed along with the request. Yeah. So again, that is all abstracted away in a much easier way. Of course, it can do streaming. Let me actually show this, because it's a lot simpler to use this rather than the individual SDKs. So let's go back to Semantic Kernel, this one. And let's start with the simple one. So we start with a kernel. Of course, we bring in the library, bring in the API key. We already know that. So we have the kernel, create builder, gives you the created kernel. And then we can add all kinds of services. In this case, OpenAI chat completion. If you want to use Gemini, then you just add Gemini chat completion. If you use Claude, it's something else I don't know by heart, but it's pretty much the same thing. It's always, you can add multiple ones as well. right? You can add as many services as you want to the kernel. And then you ask it to invoke a prompt with a passed-in prompt, and done. Yeah? And you get back a response. Like I said, all the things around message history, all of that is available here. So in this case, I just use chat histories. We add to that chat history all the messages coming back from the model, as well as the messages that the user has entered, so that the model has the full context that will go back and forth between the model and the application. Like I said, it can do everything. So also image generation works. So for that, you just add, in this case, not the chat completion, but to add OpenAI text to image in this case. If you want to go from a text to an image, that's another service that you add. So the kernel, you add services to. That's the idea. Same prompt, and now you do a generate image async, passing in the width, passing in the required height. So this is a lot simpler, right, than using the details of OpenAI's SDK. It's an abstraction on top of it. And what is also simpler is the use of plugins. Right? Remember that whole shebang of code that I needed to do to actually get OpenAI to do the back and forth? The kernel is the one that does it all for you now. The kernel is really the component that sits between your app and the model. So if now you want to register functions, or tools I should say, actually in the case of Semantic Kernel I should say plugins, you actually just need to create a class. And that class is actually called a plugin. And on that plugin, the class itself you don't need to do anything with, but in there you create one or more kernel functions. And the kernel functions, well, they are wrapped, go to the model. Because of their description, they can be found by the model and can be then invoked. Do we need to do that whole switch that the model can say, I want a tool call, I want a response? Actually, no. Look here. If we go here, we basically just say to the model, to the kernel, import plugin from type. You can add, again, as many plugins as you want. They're all sent along and done. The whole communication, back and forth, we don't need to write it, abstract it away. So that's how Semantic Kernel makes this whole thing so much easier. Yeah. Down here at the bottom, I think I'm doing one with multiple plugins, as you can see here. So this is, you can add multiple plugins, multiple functions in one go. Again, don't do too many, because if you go overboard with too many functions, it will actually confuse the model. The maximum in general is around 15, 20 is really the maximum of functions that you can send along with your request to the model, right? So this looks a lot simpler, right? Yeah. So this abstraction, it's an abstraction. So I think I showed you pretty much everything I wanted to show you about Semantic Kernel. So let's go back to the version of Bethany's Pie Shop. I'm not going to be showing you anything new here, but I'm going to show you how I did the code in this case. So Semantic Kernel, this one. I can run it, but it would be the same. Just to refresh your memory, I can go here and I can add a pie and I can give it a description, generate a short description. All of that is now done by Semantic Kernel, but the result is the same. But the code, however, is a lot simpler. If you look at, because of the fact that this is using the kernel is a DI, we can actually rely on the things in ASP.NET Core to do the DI stuff. DI being dependency injection, I assume you know. In my program, I register my kernel. See, builder.services.add kernel, and then to the kernel, I then register the AIs services I want to use. In this case, OpenAI chat completion and OpenAI text to image. Could use the other ones as well. Now they are known. The kernel is known at application level. Right? It's registered in the DI. So now I can actually just rely on that to get me back the kernel in my application, in my components in this case. Yeah? So I do an injection here of the kernel, and this is one of the downsides of Semantic Kernel. You always have to pass the kernel around. Yeah? That's how it works. It's not. This is basically the prettiest thing I can do by registering the kernel in the DI and then injecting the kernel, and then from that I can use the kernel inside of my components. That's what I'm doing here. Yeah? So this is a downside. Come back to that in just a second, that's the last part. And then we can basically get, in this case, the chat completion service, and then when we do the short description, we say, again, streaming, of course, works, we have the prompt, and we then ask the chat compilation service to get, in this case, as a streaming, the PI description or whatever that you want it to get. Cool? Works well still, although it has now been superseded. So let me jump a few, because this we've already done, there we go. So in this last part, I may go a few minutes over time, apologies for that. So what we have actually done now is, in fact, we went around the whole agent thing. Yeah. Although, in fact, my application was an agent. Yeah. But I didn't treat it as such. Yeah. I was basically having my application code talk with the model. Yeah. The whole thing about agents is really having an instance that you then talk with, that will then do the communication with the model and the tools and I don't know what for you. That is the whole idea behind agents. So far, basically, our app was the agent. We spoke with the app, and the app went out to do the things we wanted it to do. So agents are nothing really special. They are basically, from the Latin, agere means doing something. So basically, an agent is an autonomous system that does what we've just shown as a single instance. And of course, you can have multiple instances in your application of agents. Yeah? So an agent uses a model, uses plugins, uses memory. I've not touched on memory, but I'm not going to go there here. But basically, it's just the same thing. What we have done now as the application, we wrap that in an agent, and we can have multiple agents, and we talk with the agent, and they can talk with one another. Yeah? So they can work collaboratively together. Yeah? So you should easily think, or you can easily think of agents as such. Say that you are asked to organize an event like this. If you are the only person doing that, that means single agent. Yeah? You have to do the venue, you have to do the catering, you have to do the speakers, and you have to get the speakers here, so the travel. Yeah? You probably will make a mistake somewhere, because it's too much context. It's too much going on. The whole idea behind agents is, well, you don't have someone doing that, but you and a few other people are doing that, and each of them takes a specific task, each at which you're good at. Right? So you basically split up the tasks between a set of personas, agents, whatever you want them to call them. And then someone does take care of the venue, someone does the catering, someone does the speakers, and someone does the travel. Yeah? Less burden, less possibilities to actually make mistakes. That is the whole setup around agents in a nutshell. So basically, like I just said, you assign agents to specific tasks. That's pretty much what you will do. You make it less complex. Because if you give a model too much work, it is going to fail. It's going to do something wrong, just like you would do if you have too much on your plate. Models often are associated with asynchronous tasks, being you ask it to do something and it will come back at some point. That's pretty much how you do your work as well. Your boss asks you to do something. And agents are also very, let's say, good is not the right word, but associated with, let's say, underspecified tasks. Again, if your boss asks you to do something, it's probably also underspecified, right? So the agent will actually be responsible to think about the task, the reason about the task, maybe to split it up, and also ask other agents, sub-agents possibly, to do stuff. That's what it is. Agents are just following the same flow as we just explained. So now it will be you, the user, who talks with an agent, and the agent will do the communication with the model. That's pretty much what it is. This is a graph that I stole from Microsoft's website, so you can find it there as well. But notice what is now going to be the loop between the application, or the user, let's say, the agent, and the model, and eventual tools. Pretty much what we just did is now moved a level to the right. Now it's moved to the level of the agent. The agent will do the communication with the model. The model will say, hey, I need you to invoke this tool. The agent will go and execute that tool. The agent will then go back to the model with the result of that execution of the tool, plus the model, and then come back to the agent, and then only the response will go back to the user. So there's an actual layer in between that you as the user now talk with. That's the whole thing about agents. You can use agents pretty much for everything, but again, don't go overboard. You don't need agents for everything, because everything that we did so far, very well doable without agents. So they don't need agents because everyone is talking about agents. There are definitely cases where agents make sense. A couple of things like customer support. If you're building a customer support application, you might actually have different agents that are responsible for different types of tasks that the customer support needs to do, like fetching data from a knowledge base, fetching information from a ticket base, and so on. So you could split that up, and you possibly will have better results than having it all done in one thing. You see a few others here as well. Agents are also not always to be used, like I said. Don't start throwing away your ability to code. If it's something that is very specified, a function, doing it yourself is still better than having an agent do it, just as a reminder. Don't go overboard with all this stuff. Now you can do semantic kernel agents. Semantic kernel has been around for about 2 years, and agent support has been added there about a year ago, I think. But Microsoft decided about 3-4 months ago, so October 2025, to come out with a new framework that is really specifically aimed at agent building. And it's very well cleverly called the agent framework. Yeah. So agent framework is really focused on the building of agents. The name gives that away. And it is actually the natural evolution of semantic kernel. I didn't remove semantic kernel from this presentation because if you know semantic kernel, it's very easy to navigate or to upgrade, let's say, to agent framework. Interestingly, there is a very long prompt that you can find on the GitHub of Agent Framework that actually is a Copilot prompt that you can use in semantic kernel projects and have it upgrade it for you to Agent Framework. And I tried it, it works quite well. Yeah? So you don't have to do it yourself even. Yeah? A lot of the things will sound very familiar. It can do everything that we've seen, chat completions, text, image generation, tool. It has better support for MCP than semantic kernel because MCP is newer and Agent Framework is also newer, hence the communication. Threading is now what is history. It's called now agent thread. Agents can also do the whole history thing. Memory is also better support than in semantic kernel. Semantic kernel required plugins for that, quite difficult. So it's actually taking the best from semantic kernel and AutoGen, which was another framework by Microsoft. And so they've taken the simplicity from AutoGen and merged that with the capabilities of semantic kernel. So all the things that we saw about being an abstraction is now also available in Agent Framework. Now, talking about simple, the code is not always very compact. So because now there is an extra layer you also need to take into account. You have to build that agent. Then you say, I'm going to talk with OpenAI. I do a get chat client, and then I do an agent on top of that. And from then on, I work with my agent rather than directly with the code. That is my application. So the agent is that layer in between. We make a chat message, and we ask the agent to run that chat message, basically being the prompt. So that is how you now do it. Yeah? Again, you don't need an agent for everything. Yeah? You can actually directly just invoke code in here. Like I said, the history is done using the agent thread. This is very simple. You just pass the agent thread along with the invocation of the agent's call to run a prompt, and the history will automatically be passed along. And this will sound very familiar. The way that you work with tools, plugins, is the same as in semantic kernel. So it's now called a description that you pass in. You also see here that you have to also be clear about what the role of the parameters is, because otherwise the model can't invoke it. It stays exactly the same. And now there's an extra line here, and instead of directly invoking it, that you now do a create agent and you pass in the tool or tools that you want the model to know about. Yeah. So all that you know about semantic kernel applies in Agent Framework as well. Like I said, Agent Framework is not yet ready. It's in preview. It will come out somewhere this year. And it's still changing. There's still code that is changing in between updates. So it's still in preview. Other things it can do, it has support for MCP, better than semantic kernel. Plus, it also can expose an agent as an MCP tool. That's also something that semantic kernel, as far as I know, can't do. It has support for OTel. It has support for middleware. Semantic kernel also had that. Memory, like I said, is also supported. And this is where I think the biggest difference is between semantic kernel and Agent Framework is the way that it works with the so-called workflows. Agents are typically aimed at working together, concurrently, sequentially, whatever. And this has, as agent framework, has this thing called workflows, where you can actually specify how your agents should actually do the work, in parallel, sequential, whatever. There's quite a few options there. I'm not going to show that here because I don't have time for that. And this is also something that has changed between versions a little bit. This was actually quite hard to get right with Semantic Kernel. So I'm happy that Microsoft has improved on that thing in Agent Framework. And so I'm quickly going to show you the code, and then I'm going to allow you to grab some lunch. So let's quickly go back to the last one. I don't have this, let's say, embedded yet in Bethany SpyShop, but I will show you very quickly how this, what this will look like. So if we do a very simple agent, all the way up here, this again will now already feel familiar. You make an AI agent, pass in the API key, get a chat client, and then use the agent, and use also that agent to communicate with. Then you use a chat message, you run the agent passing in the chat message, and you get back a chat completion. But like I said, this has more capabilities. One of the things that is currently not final yet is, for example, the support for displaying the reasoning. Reasoning is very important because reasoning is actually that you see how a model is splitting up, thinking about the task, splitting up the task, possibly in multiple agents if necessary. So here you see I still have to disable the warning here because otherwise it doesn't compile. But here you can see, for example, that I have the reasoning options included. So if you run this, I will not do it here, but then you will see how the model is reasoning about this flow. And finally, like I said, it has support for these workflows in which this is quite a lot of code, but here I can, for example, specify somewhere that, there we go, so that I have multiple agents and I want to execute them in a concurrent way. And there's multiple options on how you want your, how you want to orchestrate, let's say, your different agents. All right, I am 5 minutes over time, so apologies for that. I do want to quickly summarize what we've seen here. So we've seen, hopefully, I've given you some ideas on how you can, let's say, delight your users. If you build .NET applications today, I think making use of AI in your applications can really help the experience that users are getting. It's very natural to do it. You just use a couple of the options that we have here. Don't go overboard with agents. You don't have to use agents. All these simple things I showed you in the beginning, we can already do by just including the OpenAI library. I hope you enjoyed it. I hope it was useful. Thank you. And if there's any questions, let me know.